Hi, I am Gisli Dunkel, a software engineer here at Scalemem, and today I want to give a brief demo of our Scalemem Fabric Control Software. So the basic objective of the Fabric Control Software is to manage and monitor a CXL cluster. And here's an example of a very simple quote-unquote cluster with two hosts and four devices shared between the host through a switch. And the switch allows us to allocate devices to each host dynamically over time as needed. To achieve that, we have the CXL Fabric Manager associated with a switch. And as the CXL cluster increases in size, we're going to have multiple switches. And each switch has a Fabric Manager associated with it. On top of all that, we have our Scalemem Fabric Control Software that has a cluster-wide view and management capability, and this becomes indispensable as the cluster grows in size. So this is an example of a memory scale-up use case where you can achieve big performance benefits through increased memory capacity and increased memory bandwidth. And you can also achieve cost and energy benefits through pooled and tiered memory. So for the demo, I'm going to focus on the simple setup here. In fact, I'm going to make it even simpler and just have three CXL memory devices shared by the two hosts. And I'll color code them so that we can keep track of who owns which device. At the moment, the Fabric Manager owns the three memory devices, so none of them have been allocated to the host yet. Then we have a simple orchestrator script here to illustrate integration with an orchestrator or resource manager. And all it does is monitor the memory usage on each host. And as the memory usage gets high, it allocates more memory as needed by telling the Fabric Manager to allocating a CXL memory device to that host. So here we have allocated a device to host 1. And we have a couple of simple workloads running on these hosts that just consume and release memory in a cycle over time. Host 1 is getting low in memory. We're allocating another device. In the meantime, host 2's utilization increases and the script allocates a device to host 2. And now host 2 wants a second device, but there are only 3 available. But host 1's memory usage is now going down, and we can therefore unplug that device from host 1 and give it instead to host 2. So we can see how this works in action here. Here you can see a Grafana dashboard where we're pulling some metrics from both hosts. The yellow line is the total amount of available memory to each host. It keeps going up and down because the script detects a low memory situation and attempts to allocate an additional device to that host. But as the other hosts gets a low memory situation, the script will then try to take that device away again and give it to the other host. So that way the one device is getting passed back and forth between these two hosts. And so this demonstrates that we're able to keep the systems running normally while we add and remove system memory from the hosts. So in order to achieve this, we have a Scalemem agent running on each host that when we add memory, we bring it online for the operating system to use. And when we remove memory device, we first have to make sure that any used memory on that device is migrated away before we can safely unplug it and pass it on to the next host. I hope this very simplified demo helped to understand the fundamentals of our Fabric controller and how, especially when scaled up, it can reduce costs and energy consumption while boosting both capacity and performance. For real-world deployments, each Fabric controller will be able to manage clusters consisting of hundreds of memory modules used by hundreds of hosts. Thank you.